All right, this video is over scientific notation. You've seen it in biology. I know you have. You've seen it for sure in math. You're going to see it now in chemistry again. So scientific notation is used to represent numbers that are very, very big and very, very small. Considering this is chemistry, dealing with little bitty atoms, you're mostly going to be dealing with numbers that are very small, unless we're dealing with a lot of atoms, and in which case it's going to be numbers that are very big. So you can see you're going to use this concept a lot throughout the entire year, and you'll use it again in physics next year. So the big thing in your calculator is that you will never do the times 10 exponent. So if you're hitting the X button, and then the 1, and the 0, and then the little caret, don't do that. That will give you the wrong answer sometimes. It will not ever give you the right answer all the time. So what we're going to do is there's this little EE button on your calculator. It stands for enter exponent. It's normally you got to hit the second button first, and then find the EE's, the elevated one. I'll show you all where it is in class. And some it's the chi -1. On others, if somebody types now, I can't remember them all. But we'll find it in class. I don't want you to worry about it right now. If you go to the calculator on my website, it has an actual EE button for you to pick. But when you hit the EE button, it only gives you one E. So don't hit it twice. It'll give you a context error or something like that, syntax. But just whatever you do, don't do this. Don't do the X10 caret, because that will give you the wrong answer from time to time. So to convert from decimal form to scientific notation, there's this big long example. Move to the point where there's only one non-zero digit to the left of the decimal. Then however many places you had to move that decimal, how many numbers you had to go through, that will be your exponent. If you moved it to the left, your exponent is positive. If you move to the right, your exponent is negative. You can also just type the number into your calculator and move it over to scientific form. But if you don't have a calculator, this will work just fine. Next, to convert the other way from scientific to decimal, you move the decimal point to the right if the exponent is move the decimal point to the right if the exponent is positive, and add zeros if needed. Move it to the left if the exponent is negative, and add zeros if needed. Remember, the exponent will tell you how many times to move the decimal. So, if you move to correct scientific notation, because sometimes your calculator will do it wrong, you move the decimal so that only one non-zero digit remains to the left of the decimal. Okay, you're going to increase the exponent if you move the decimal to the left, and decrease if you move to the right. This is no different from the rules we just showed you, but sometimes you will have to fix it because it'll give you a couple of digits in front of that decimal point. So just be wary of that. Be careful with it. So convert to decimal point. Once again, you can just put your type this into your calculator, put it in the scientific notation, and it'll check it for you, or hit enter. Good way to check your work, but you've got an exponent of 3. It's positive, so you're going to move the exponent 3 places to the right. So it's right here. It's 1, that's 2, that's 3. It's going to add 2 zeros, so it's 1, 1, 0, 0. Now the negative in the number does not matter, so you don't really care about that at all. You still include it in your answer. So our answer is going to be negative. Now we got an exponent of 5. It's positive. It goes to the right. I don't know why I put that there, but I did. So 1, 2, 3, 4, 5. So we're going to add 1, 2, 3 zeros. So it's negative 2, 3, 5, and 3 zeros. We put the commas in there for those that need it. Then number 3. Now we have a negative exponent. If it's negative, move to the left. Think of that negative pointer as pointing to the left. So there we go, 1, 2, 3. We're going to have to add 2 zeros in front. We always have that placeholder that's 0. So at 0 point are 2 zeros, then it's 1, 1, 2. Number 4, we have another negative exponent. So again, we're moving to the left. We're still going to keep our negative sign. And it's going to be 1, 2, 3, 4, 5. So to add 1, 2, 3, 4 zeros. So always start with a 0 point, and then 1, 2, 3, 4 zeros, followed by all the numbers. 3, sorry, and it stays negative. That way is easy. Now These are on the right side. This is the bottom part of the right side. Now convert this to scientific notation. So our decimal point is actually right here. And we got to get to one non-zero digit to the left of the decimal. So let's move this till we have one non-zero to the left of it. 1, 2, 3, 4, 5, 6, 7. So we can do 7.51 times 10, and we went to the left, so it's positive 7. We have a big number, so our number needs to be big. There we go again. Our decimal is actually right here. So it's 1, 2, 3, 4, 5. So we can still keep it at negative 2.349. And then we do times 10. We moved it 5 places, so there's our exponent. Going the other way. Now we're going 1, 2, 3, 4, 5, 6. So it's 2.31 times 10. Now this time we move the decimal to the right. So if we move to the right, it's negative 6. Here we go again. We have a negative sign, so keep it negative. 1, 2, 3, 4, 5. It's 5 again, so it's negative 3.549 times 10. Move to the right, so it's negative 5. That's all there is to it. Once again, put these into your calculator, put it in scientific mode to check your answers.